Welcome to the Module 1 of HPLC course. If you're completely new to HPLC, this module will give you a strong foundation. We will break things down step by step, nothing complicated, just clear explanation. In next few minutes, you will learn the basic principle behind how it separates the compound, the different type of HPLC and when to use them, what parts makes up the HPLC system, key terms that every analyst should know, and finally, how HPLC is used in real world. Let's get started with the basics. What exactly is HPLC and why is it such a big deal? At its core, HPLC is a high-tech way to separate the compound in a liquid mixture. The idea comes from the technique called column chromatography, where a sample is poured over a column filled with solid substance. The different compounds in the sample travel through the column at different speed and separate as they go. But traditional columns rely on gravity. They are slow, less efficient, and not ideally used for a precise measurement. That's where the HPLC came. Instead of gravity, HPLC used a high pressure pump to force the liquid pass through a tightly packed column, which dramatically improves the speed, resolution, and reproducibility. The system follows this flow. The pump pushes the mobile phase through the system. Injector adds the sample. The sample enters the column where the separation happens. Then the compound reaches the detector, which records them and sends the data to the computer. Simple idea but powerful results. Now let's break down how HPLC actually separates the compound. We got two key players here. The mobile phase, which is a liquid solvent that flows through the system, and the stationary phase, which is a solid material packed inside the column, usually silica-based material. When the sample enters the column, each compound in it interacts differently with the stationary phase and the mobile phase. Some compounds are more attracted to the stationary phase. They stick around longer and move slowly. Others prefer the mobile phase. Therefore, they flow right through it. Because of these different interactions, the compound separate over time and exit the column at different retention time. These are recorded as peaks on chromatogram, and that's how we identify and measure the compound of a mixture. Depending on what kind of sample you are analyzing, you will choose the right mode of HPLC. Let's go through the main ones. Reverse phase HPLC is most common. It uses a non-polar column and a polar solvent, water or methanol. It is great for small organic molecule and especially used in pharma. Normal phase HPLC use a polar column and a non-polar solvent, helpful for separating lipids or a very hydrophobic compounds. Ion exchange HPLC separate compounds based on their charge. It is especially useful for amino acid, peptides, and proteins. And finally, size exclusion chromatography, which separates the molecule by size. Bigger the molecule comes out the first, and smaller one later. This is commonly used for protein and polymers. So, depending on the chemistry of your sample, pick the method which gives you the best separation. Every HPLC system is made of few essential parts. Here are some of them. The solvent reservoir, which holds the mobile phase, like water, methanol, or acetonitrile. These solvents are need to be pure. The pump delivers the mobile phase at a high pressure to keep the flow steady and controlled. The injector introduces the sample into the flow path. You can do it manually or by using an auto sampler for consistent result. The column is where all the magic happens. It is tightly packed with stationary phase particles that interact with the compound and separate them based on their property. The detector watches for the compounds coming out of the column. UV is the most common and sends the signal. Finally, the data system converts those signals into chromatogram, which later you can identify and measure. To understand and work with HPLC, you need to know some basic terms like retention time. It is the time taken for a compound to pass through the column and reach the detector. It helps us to identify the compound. A peak is a signal created by a compound when it is detected. Bigger the peak usually means higher concentration. The baseline is the flat line on the chromatogram when no compounds are being detected. A noisy baseline can mean something is going wrong. Flow rate refers to how fast the mobile phase is moving, like 1 ml per minute. Isocratic illusion means the mobile phase composition stays the same throughout the run, while gradient illusion means it changes, like from more aqueous solution to more organic solution. So where is HPLC used? Pretty much everywhere. In pharmaceutical lab, it is used to check drug strength, identify impurity, and make sure the tablets are stable over time. In food industry, it helps to detect preservative, colors, and artificial sweetener. In environmental testing, HPLC is used to monitor the pesticide residue in water or soil, or check the pollution level. It is safe to say, if you care about precision and safety in a product, HPLC is probably behind the scene.